Today we start Chapter 4. Chapter 4 is a very important chapter because we're going to talk about one of the fundamental concepts in all higher level math called a function. But first we're going to start talking about relations. A relation is just a set of ordered pairs, and if you can look below, you can see what I mean by a list of or a set of ordered pairs. A set has these squiggly brackets, so here's a set and here's a set, and we could create sets out of these other relations. And a relation having a set of ordered pairs, this is an ordered pair, April, comma 1. So April is the first element and 1 is the second element. June, comma 7. November, comma 25. First element, second element. These are ordered pairs. So the order is important in this pair. It's not 1 comma April, for example. Here's another set of ordered pairs. They're all numerical. They don't have to be numbers. They could be words. They could be anything. Here's a relation, C. He's called a mapping diagram. So up here, relations can be lists, like these two are lists. They can be a table of values, like an XY table. If you look on your calculator, the XY table could be represented as a relation. Here's a graph over here, relation D, or a mapping diagram. This relation C is called a mapping diagram. So in this relation, the first element is a 2 and the second element is prime. First element 13, second element prime. First element 9, second element perfect square. First element 5, second element prime. So if you can imagine, these could all be listed like these relations if you wanted to set up squiggly brackets, and this be the first element and this be the second element in them. And here's another relation. This is just a graph, but you can go through this graph and find a whole bunch of XY pairs. Like for example, this right here, this point would be -1 comma 0. And you could set up a relation. You could list a whole bunch of XY values off from that graph. So these are all relations. Now here's some important vocabulary words that we'll talk about a lot this chapter. The domain of a relation is the first element. So over here, these are the first elements. A range is the second elements. The first elements are called independent variables or independent elements. The range is called the dependent. So if we go back up here to relation A, if we want to list the domain of relation A, we're just going to find the first element of each ordered pair. So the first element of each ordered pair in relation A is April, June, and November. So I'll write that down. April, June, November. And that's the domain. Whoops. That's the domain, April, June, and November. A little squiggly bracket here. Now the range is the second set of numbers. So in relation A, the second is 1, 7, and 25. So the range of relation A, 1, 7, 25. In relation B, the domain is 2, 4, -5, and -11. Domain, 2, 4, -5, -11. The first elements are the domain. The second elements are the range. So these numbers, -3, 8, 5, and -3 are in the range. In relation C, the mapping diagram, the domain are the first elements, so 2, 13, 9, and 5. And the range is the second element, which is prime or perfect square. So you can see domain and range don't have to be numbers, although they usually are. And in letter D, the domain, well, if you wanted to go along this graph, you could pick out a million different points. It doesn't just have to be on integer values. For example, if I wanted to try to figure out this XY value up here, it would be like -1.5, positive 0.9, for example. Or if I wanted to try to pick out this value back here, it would be -2.2 maybe, comma -1. So there are an infinite number of points on this connected graph. This is a connected or a continuous graph. And in that case, the domain or the first elements are the x values, and that's all real numbers. In other words, you can, for the x value, you can pick out any x value, and there will be a point corresponding to that x value on this graph. And the same thing with the range. If you want to try to pick out any y value, you can pick out any y value on this, the whole continuum, and no matter what y value you pick, there's going to be a point on this graph that corresponds to that y value. So the range is all real numbers. And I have a fancy way of writing all real numbers, just a shortcut. I use this fancy R. So whenever you see me write this fancy R, that just means all real numbers. So the number of elements in domain and range are not necessarily equal. For example, in relation C, I have 4 elements in the domain, but only 2 in the range. And if you have anything appearing twice, it's not listed, it's only listed once. Down here, we have a graph that's a little bit different than a graph above. This graph starts over here and ends over here, and we're going to talk about the domain and range. Well, the domain on a graph is the x values of this graph, and the range are the y values. Now the domain, x's, you know x's go left to right. So if I want to try to figure out the domain of this, I pick out the leftmost point of this graph, which is over here on -4. So I'm just going to zoom in on this -4. So this graph starts right here, and it ends all the way over here at -5. It doesn't go any further to the right. So if I want to look at the domain is like this number line here. This x-axis becomes a number line. It starts at -4. It ends at +5. So the domain are the x values, everything in between -4 and 5, not all real numbers. But this has an open circle, which means it's not included. So we can say -4 is the leftmost point. It is less than x, hopefully you remember this like an and inequality, is less than, the highest x value is a 5. So domains go left to right, -4 to 5. And actually it's less than or equal to 5 because this circle is filled in. Open circles, strictly less than, filled in circles, less than or equal to, just like a number line. Now the range is the y values. So the y values go from lowest to highest. So if I pick the lowest point on here, it would go down here. Now we're looking at the y-axis, not the x-axis. So the range on this graph, here's the highest point right up here. So this y values, these y values go right down here from a lowest of -2, and it's a closed circle, so I'll have a less than or equal to, and the highest is a 5. So here is the range of this function, -2 all the way up to 5, lowest to highest. So that's how we write it. -2 is less than or equal to y, remember these are the y values, is less than 5. And in a few moments we'll fill in the function in the one-to-one part. Now we're going to look at example 2, which is just a parabola. So what we're going to do is try to figure out the leftmost and rightmost point of this parabola. Well, if you see arrows, these are arrows going on the ends of those. If these arrows are pointing to the left and right like this is, there really isn't a leftmost point. I really don't stop my graph here because this graph, this window is small, but if I expanded the window, this would go on to the left forever and it would go on to the right forever. So let's just mark this. This goes to the left forever. That's what that arrow means. It goes up forever and to the left forever. And then over here, it goes to the right forever, because it just slowly goes in those left and right directions until the end of time. So whenever a graph goes left and right forever, you really can't put your paper and say, oh, it stops there, oh, it stops there, because it doesn't stop. This graph stopped. This graph doesn't stop. So the domain is all real numbers. Here's my fancy R. I'm not going to waste my time writing out all real numbers when I can just abbreviate it with that R. Now the range is the lowest to highest. Well, does this have a lowest point? Well, it certainly does. It doesn't go below -4. Here's the lowest point. It doesn't go down forever, but these arrows say it goes up forever. So what is the range? What are these y values on this? Well, there is a lowest of -4. It does go down and touch -4, but it goes up forever. So what I would say is all these y values are greater than or equal to -4 because everything is above -4 on this graph. Moving on to this next graph. Well, this isn't going on forever. There aren't any arrows. So I would go from -2 to 4, leftmost to rightmost, -4 or -2 to +4. Those are my x values, left and right. So we'd say -2 is less than x is less than 4, and they're open circles, so we use those symbols. Well, the range is lowest to highest. Well, what's the lowest on here? Down to -4, up to +5. Remember, we're going on the y-axis here. So the range is -4 is less than y is less than 5. Bottom to top for range. The next example. Let's see, does this have a leftmost point? Yes, there's the leftmost point, so I'll go back to here. Does it have a rightmost point? Yes, over here. So what is the domain? Remember, domain is the x values. It goes from -5 all the way up to +4, and it's a closed circle here and an open circle there, so I have to write that correctly. -5 is less than or equal to x is less than 4. And then is there a lowest and highest? Well, yes, there is. There's a lowest point right here on the graph. And then there's a highest point. All the way up here is the highest point. So what are the y values? Y is range. So the y values are -3 all the way up to 4. -3, we've got an open circle here. Less than y, and we've got an open circle at the top. Less than +4. The next example. Do we have a leftmost point? Well, yes, we do. Right here is the leftmost point. The graph does not go any further than -3. Does it have a rightmost point? Well, these arrows say it goes to the right forever. So the domain, all these x values, all those x values are greater than or equal to -3. What about a range? Does it have a lowest point? Well, no, this goes down forever, because very slowly, just like the other parabola does. Down forever, very slowly, but it does head down there, and this goes up forever. So I don't have a lowest point and a highest point, so the range is all real numbers. Now this one is different. This is called a scatter plot. Scatter plots are just a bunch of points that are unconnected. So we don't go with this paper here and say, oh, leftmost, rightmost, bottom, top, because it doesn't connect. So what we have to do is list all the x values of every point. List the x values of each point. So what do we have here? Well, right here, here's a point called -4, 4. So I'll put it in a set. The domain is -4. Here's a point right here. Both of these points have an x value of -2. Let's see, here's the next point here. This has an x value. If I wrote this out, this would be 0, 3. So the x value is 0. This point here is 1, -4. The x value is 1. The x value is 2. And the x value here is 4. So list all the x values, every point you see, and you have it there. I hope I didn't skip any. And the range, you're going to list all the y values of each point. That's what range is the y values. So let's see, I guess I'll start with the bottom point here. You don't have to go in this order. So the y value here is a -4. That's a terrible squiggly. Oh well. This y value here is -3. Going up to this point, this y value is -1. This y value is 0. This y value is 1. This y value is 2. The y value is 3. And this y value is 4. So remember, scatter plots have a different way of saying domain and range because you have to make a list of all of those values. And now we're going to talk about what a function is. This is the basic concept of this chapter, functions. And these are a couple different ways to write a function. And hopefully you covered functions in Algebra 1. Maybe you remember them. I hope you do. But a function, the definition, so we'll just put a DEF for here for the definition. The definition of a function is just a rule that assigns exactly one y to every value of x. Okay, lots of times they're written as equations. Not every equation is a function. Sometimes you're going to be asked to recognize whether something is a function from an equation or maybe from its graph. Okay, if you have an equation like y equals something or other or x equals something or other, if you have an equation and you're asked to figure out whether it's a function or not, and we'll talk more about it in a little bit, you're going to look for a y. If there isn't a y in your equation, then it is an equation of a vertical line. Like x equals 6 or x equals -1, for example. Those are equations of a vertical line. If I wanted to graph like x equals 6, I'd go over to 1, 2, 3, 4, 5, 6, and this line right here, if these are the xy axis, this would be x equals 6, for example. So if you don't have a y in your equation, no y, then it's the equation of a vertical line like these. They're not functions. Now, if y is squared, then there is not exactly one y for each value of x. When y is squared, there might be two possible y's for some value of x. For example, you might say y squared is equal to 4x. When y is squared, this is not a function because the next line down you could say y is equal to the square root of 4x plus or minus, right? If you take the square root of both sides, y can be equal to 2 square root of x if you take the square root of that, or y could be equal to -2 square root of x, because when you take the square root of both sides you do plus or minus, if you remember from the last chapter. So that's why if y is squared, it's not a function. If y is there and it's not squared, then it is the equation of a function. For example, y is equal to x squared minus x plus 6. That is the equation of a function. Y is there, y is not squared. So that's from an equation. Sometimes you're going to be asked to look at a graph, and this is the easiest way. This is the easiest way to tell if something is a function, because you're going to do something called the vertical line test. I hope you remember that one from Algebra 1 also. What a vertical line test does is you draw a vertical line, that's the up and down lines, on the graph. If each vertical line intersects the graph at only one point, then it is a function. In other words, if there is more than one point of intersection of the vertical line and the function and the graph, then it's not a function. Okay, we'll also talk about a horizontal line test. Horizontal lines go left to right. We'll talk about that in a little bit. But here's some practice we're going to practice figuring out whether these things are functions or not. First we have 4 equations, then we have 4 graphs. So from the equations, y is there, y is not squared. Yes, this is a function. This one, y is not there. That's the equation of a vertical line. So that is no, it's not a function. This one, y is there, but y is squared. So y is squared, no, that's not a function. And here we go, y is there, y is not squared. Yes, this is a function. So from an equation, you use these rules. If you just have a graph, now these are like 8 different examples. 1, 2, 3, 4. Here's example number 5. You have this oval. Well, if you draw a vertical line, and I abbreviate a vertical line test, VLT, vertical line test. Well, this intersects this graph twice. So this is no, this is not a function. Intersects twice. Actually, maybe I'll use a different color on this vertical line. This vertical line intersects the graph twice. Here's another graph, this triangle. If we draw a vertical line here, it intersects the graph 2 times, so this is no, this is not a function. Here you have a line that it's kind of going up at a rapid pace. I guess I'll just put arrows on the end of it. But if you draw any vertical line through this graph, it doesn't matter where it is, it'll only intersect it once. So this is yes, this is a function. And then over here, again, if you take a vertical line and you draw it at any point, any vertical line only intersects this graph once. Maybe we'll write that down to summarize. Any vertical line only intersects curve once. And since that's the case, I'll just draw this as my vertical line, but you could draw it anywhere you wanted to. So if this is the case, yes, this is a function. And that's it for today.